Okay, so this is lesson 87 for Algebra 2. It's due Monday the 11th, and it's evaluating log. So I'm going to show you a different way than the book shows you to evaluate these logs, okay? Because we can use what's called a change of base formula. So that's what we're going to do. The issue is this exponent. You have to go ahead and follow your rules, laws of logarithms, properties of logarithms, and move that 3 in the front and have log base 4 of 16x, okay? Then you can use your change of base formula. So 3 times log of 16x over log 4. Then you can plug in the 256. So 3 times log of 16 times 256 all over log 4. And then you're going to type that in your calculator. So you're going to put 3, and then you're going to start parentheses because the 3 has to go to both, has to go to everything in there. So 3 log of 16 times 256, close parentheses, and then divide that by log 4, and then close parentheses, and then your answer is 18. Equals 18. Okay. Okay, so let's look at another one. Let's see, we've got log base 3 of 27r all to the 4th. We want to evaluate when r is 243. Now, again, on this, you know, if this was base 10, or if this base wasn't here, we just type it in the calculator. Log 27 times 243 all to the 4th, or put the 4 in front, because the 4 has to be in front. You have to move that exponent. It can't stay where it is, okay? So we move the 4. Then we can do the change of base formula, where log 27r over log 3. And then for r, we can just plug in the 243 right here. And then type it in the calculator. So 4 log 27, 27 times 243, close parentheses, divided by log, yep, I messed up. Let me clear it off. I've got to do 4 parentheses, then log 27 times 243, close parentheses, divided by log 3. Because that 4 has to be an exponent. It has to be distributed to all of this, okay? So you got to make sure you have a big set of parentheses so that it affects everything. And then it equals, it's 32. We're using change of base formula, okay? Then it'll give you some natural log things. Let's see, natural log of 7e all squared. Natural log of 7e all squared. So you could do 2 natural log 7e. You know, we've done this before. 7 plus 2 natural log e. 2 natural log 7 plus 2, because ln e is 1. And then you can type that in your calculator. 2 natural log 7, close parentheses. Some of y'all do not close parentheses. Plus 2, and then round it to whatever we're asked to round to. I'm going to give 3 decimal places, so 5.892. But the natural log ones like this are easier to take apart than those LOG ones. So that's why on the LOG we're using the change of base formula. So let's try another ln 12e all cubed. So we're going to move the 3 in the front. So ln 12 plus 3 ln e, because that 3 has to be distributed, has to go to both of them. So 3 ln 12 plus 3, because ln e cancels to a 1. 3 times 1 is 3. And then again, type it on your calculator. 3 ln e 12, close parentheses, plus 3. And you get about 10.45. And we go to the nearest hundredth. Okay. Then they just give you some more. Let's see. Log base 100 times 10x squared. So again, move the 2 in the front, and then we're going to do the change of base formula. We want to evaluate this when x is 1,000. So I'm going to have log. Now I'm going to skip some steps here because I've gone over them. So I'm going to go ahead and plug the x in, doing the change of base formula. So log of 10 times 1,000, put the 2 in the front like I'm supposed to, divided by the log of 100. Because remember, it's log of the argument over log of the base. And then you just type that in, 2 parentheses, log 10 times 1,000, or you can type in what that is. Close parentheses, divided by log 100. And then close parentheses twice. Okay, so it looks like this. 2 parentheses, log 10 times 1,000 divided by log 100, and you get 4. Using the change of base formula. Let's see, which one do I want to do now? We've got a log of base 4 to 2x cubed. And what happens here is they want us to change it to ln, okay, to a natural log. So we're going to put the 3. We are going to do the change of base formula. And then we're going to simply put ln's in. Now, what is our x? Our x is 6. So all we have to do here is make log ln. So 3 times ln 2 times 6 over ln 4. So that would be 3 parentheses, natural log of 12, I'm going to go and put in 12, divided by natural log of 4. So it would look like that. And you get about 5.377, about 5.377 on that. But that's all you have to do. Do the change of base formula like I've shown you, then change the LOGs to LNs. And remember that 3 on the outside has got to be there and be distributed. Okay, so let's look at another one of those. Let's see. Okay, I've got log, pretty sure it's base 9 of 3x all to the 5th, where x is 4, but we're going to change it to ln. We're going to change it to a base e. Sometimes it says use ln, sometimes it says change it to a base e. Well, ln is the base e, has a base e. So put 5 in the front. It'd be log of 3 times 4. I'm going to go and plug the x in, over log 9. So that would be 5 ln 12 over ln 9. And so we type that in. 5 parentheses, natural log of 12, close parentheses, divided by natural log of 9. And we get about 5.65. Okay, then we're going to go over again ones that I showed you on that worksheet where you've got 1,000 to 9x equals 100. So we can change these to base 10s. So 10 cubed times 9x equals 10 squared. So if my bases are the same, my exponents are as well. So 27x equals 2. Divide by 27. So x is 2 over 27. Let's see, do we have another one of those? No. This one works like it, that's an x, that's not a 48. So 32 to the 4x equals 8, because we can change 32 to 2 to the 5th. And then 8 is 2 cubed. So the 2's cancel. You're left with 20x equals 3. And then you divide by 20. So x is 3 over 20. The issue is sometimes you can't make them the same base. So sometimes it's going to look like 5 to the 3x equals 20. And you want to solve for x. Well, I can't make 5 or 20 the same base. So this is where you're going to take the natural log of both sides. So then the 3x moves in front, and you divide by 3 and the natural log of 5, because you need to get x by itself. So then when you're plugging that into your calculator, just make sure that you do natural log of 20, and then you want to divide by 3, and you want to divide by the natural log of 5. You want to divide by both of those because they're both in the denominator, so we've got to divide by both of them. And that's about 0.6205. So that's the way that works when they don't match. Just take the natural log of both sides, bump that exponent in the front, and then divide by everything but x. Leave x there, divide by everything else. Okay, so that is the lesson. Let me make the assignment and talk about a few of them. So you're going to do the warm-up on page 612. You're going to do the practice, let's see, A through F. I'm going to talk about some of them. A through F. Then you're going to do 1 through 6, 8 through 10, 12, 14, 16, 18 through 24, 27 through 29. Again, this is due the 11th. It's due May 11th, which is Monday. So you have a full week to get this done and get it turned in, to get the notes copied and all that kind of stuff. Okay, so on the warm-up, on number 4, it says expresses a common logarithm, so log base 7 of 100. So this is where you're going to use your change of base formula. So log of 100 over log of 7. Now it says represent it as a common logarithm. That means do not find the answer. Do not type this in your calculator and find out what it is. Just reduce what you can, which when we think about the top, that's log base 10 of 100. So that's log base 10 of 10 squared. Well, log base 10 cancels, so you're just left with 2. That's writing it as a common log. You're not supposed to get the answer on that. You're supposed to leave it as 2 over log 7. Because that's writing it as a common log. Then on your practice, they're pretty much like, it says change to a base 10. That's using the change of base formula like I showed you. A through D are all like that. E you'll know how to do. Now on F, the magnitude of an earthquake is the Richter scale, and its log of intensity over the initial intensity, over I.O., where I represents the intensity, I.O. represents the intensity of a 0-level earthquake. In 1989, California earthquake's intensity was 10 to the 7.1 times I.O. So we want to evaluate R. So the intensity was 10 to the 7.1 times I.O. over I.O. That's what it is. That's what they gave me. So what happens to the I.O.s? They cancel. So I've got log base 10 of 10 to the 7.1. Cancel 7.1. That's the intensity. That's how F works. So I've shown you how F works. Then let's see, you're doing 1 through 6. Oh, number 2. I need to go over number 2. You know what? No, okay. Okay, so you want to multiply by the conjugate to simplify this imaginary or complex number. So on the top, we're going to FOIL 8 minus 24i plus 2i minus 6i squared. Then on the bottom, we do the shortcut, 1 minus 3i all squared. And it's always a subtraction right there when you first do the shortcut. So then on the bottom, I'd have 1 minus 9i squared, because I'd square the 3. So I squared is negative 1. So that would be 1 plus 9 on the bottom, which is 10. So 10, because this would turn into 1 plus 9. On the top, I'd have 8 minus 22i plus 6, because the I squared becomes negative 1. Negative 1 times negative 6 is positive 6. So that would be 14 minus 22i, which we can't leave it that way because you've got to write it in A plus BI form. So 14 over 10 minus 22i over 10. So 7 over 5 minus 11i over 5. That's what the final answer is on number 2. So I just worked through number 2 for you. Make sure you show all that work. Then on number 3, you've got I to the 22nd plus I to the 15th. Remember, this is where you want, remember your scale. I is I squared is -1, I cubed is -I, and I to the 4th is 1. So if I can get these exponents to change to something divisible by 4, like I to the 20th, I squared. So the I to the 20th would cancel, would just leave I squared, which is -1. I to the 15th, you could change to I to the 12th, I cubed. So I to the 12th would go away. You'd be left with the I cubed, which is -I. So you'd have like a -1 minus I would be your final answer on number 3. Number 5 just turns into the cube root because it's to the 1/3, so that just turns into the cube root. That should help you pick out your answer. And then on 6, just simplify the expression. Don't do all that other stuff, just simplify it. 8 and 9, remember your, well, they've got it on there. Oh, you're just having to find the sine, cosine, and tangent, and they've already got it labeled for you. Remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. 8 and 9 are easier than I thought they were. Then you're doing number 10, shouldn't have a problem with 10. 12. Number 12. Okay, so let me show you number 12 because it's along this line of logarithm stuff. Log I over IO. It says to solve it for I. We're not going to solve it for I. We want to determine the intensity of an earthquake with a magnitude of R, with a magnitude R of 7. So this is what we've got. So what we want to do now is rewrite it exponentially. So 10 to the 7th, because my base is 10, equals I over IO. My base is 10. That's my exponent. This is my argument. This is my answer. So if I want the intensity, 10 to the 7th times IO. That's the intensity. This was the magnitude, 7. This was the R, and we wanted the intensity. IO is a 0 level earthquake, but this is the intensity of that earthquake, 10 to the 7th. Times IO. Then number 14 is like, you just need to make sure you show your work because they give you the answer. You just show your work on 14. Number 16. Oh, yes, number 16. I want to show you this stuff again. Number 16, although I did on the notes. You want to rewrite this correctly. So natural log of 5 plus natural log of E minus natural log of x squared. So natural log of 5 plus 1 minus 2 natural log of x. That's the way it should be rewritten on number 16. And I wanted to show you all that because some of you are missing that. So I wanted to show you that. Then let's see, you're doing 18 through 24. 18 is looking at your bell curve. So you need to draw a bell curve. It is normally distributed with the mean of 4.85, so that goes on the top. Then you've got 68% between one standard deviation above and below. Your standard deviation here is 0.068. Now, before I continue on this, I got to make sure that that's 68 because for some reason I'm questioning myself. So let me go back right quick and I'm going black for a minute. So I'm going to mess this up. Right, okay. Just second guess myself. 95%, but it is 68%. And then the bottom part is 99.7%. So you are asked on this, where did it go? Find the range of weights for the middle 99.7% of the tokens. So you're wanting these two. You're wanting these two numbers right here. So you need to add 0.068, add 0.068, add another 0.068. Then you're going to subtract 0.068, subtract 0.068, subtract it here. So you need all of this filled out. And then whatever these two numbers are, that's what you're being asked to find on 18, is the 99.7%. 19 is just finding the equation of the line perpendicular. 20 is finding the discriminant. Y'all have done that. 21, the 4 should be distributed to the log base 7x. So just rewrite it with the 4 on the log base 7x and you're good. 22 and 23 you shouldn't have a problem with. 24, you're plugging in 20 first, and then you're going to square both sides. You're going to multiply by 4 pi, and you want your answer in terms of pi. And then you're going to plug in 15 for r, and you're going to square both sides and multiply by 4 pi. And then I think you have to find the difference. Yeah, how much greater? So that shouldn't be a big deal. Then you're skipping to 27 and 28, which is from this lesson. And then on 29, explain why ln to the x squared plus 3 equals x squared plus 3, because they're inverse operations and they cancel each other out. So that's what you have to do on 29. Again, due May 11th.